In this video, I'm going to go through how to find the nth term rule for a quadratic sequence. And we're going to build up the difficulty as we go through this video. Now to start with, here are 5 questions which are linear sequences. See if you can remember how to work out the nth rule of a linear sequence. Can I suggest you pause the video now, do these 5 questions and press play again when you're ready to see the answers. The first one, each of these goes up by 3. So the rule would be 3n, and if we compare the 3 times table to our sequence, we can see it goes down by 2. So the first one, the nth term rule, is 3n minus 2. Your second one, you should have had 2n plus 1 because the sequence goes up in 2s. And if we compare with our 2 times table, it is 1 more. The next one would be 4n plus 6. Then we have 7n minus 5. And then lastly, 5n minus 2. Hopefully you got them all correct. Now let's start looking at a quadratic sequence. Now usually you see the sequence, it doesn't look any different. But let's start looking at the differences. This one goes up by 3. Then we go up by 5. And then 7. And then 9. So we can see it's increasing by odd numbers. In fact, I could easily find the next term and the term after that. Next term would be plus 11, the term after would be plus 13. But what happens if I wanted to find the 50th term? This is where we need the nth term rule. So what we do now is we check that what we call the second difference. The second difference is the same. And if the second difference is the same, that tells you it's a quadratic sequence. So this is a key fact for you to put in your notes. If the second difference is the same, then the sequence is a quadratic sequence, which means it will have an n squared in the rule. Let's get back to that one we just had. So we worked out the difference here was 3, 5, 7, 9. So the difference, second difference goes up in 2. That tells us it's a quadratic sequence. Now you may have noticed at the side I've got the steps to success. For these first few, I'm really only going to be doing sections 1, 2 and 3. The last bit I will go on when we get further through the video. So what we do is if the second difference is the same, then the number in front of the n squared is that number divided by 2. Now I've put a 1 there for now, but as we know we don't need to put a 1 in front of a letter. So when I write my final answer, I will just write it as n squared instead of 1n squared. Now, this is something I do just to check for the more straightforward ones. I'm going to write down what my first square numbers are and just compare. We have 1, 4, 9, 16, 25. Okay, so 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And what I can see is each of these is 3 higher. So that means I've just got to add on 3 to my square numbers. So my nth term rule is n squared plus 3. Let's try the next one. So we have a gap of 3, 5, 7, and 9. So our second difference is the same. I'm going to take this number, divide it by 2, and put that in front of the n squared. So now, again, I'm just going to write my squared numbers above. And I can see here each one is 2 less. So my nth term is n squared minus 2. Now these will be increasing by difficulty as we go through. At the moment, I'm just keeping this number of difference as plus 2. In my next set of examples, they will be different. Also at the moment, there is a nice little pattern for what happens here. this is not always the case. So this is when we get to these later steps that we'll be looking at. But before we do that, here are 4 for you to try. Pause the video and come back once you have tried them. Okay, so the differences are 3, 5, 7. So again, it's going up in 2s. So that means my rule starts with n squared. Write my square numbers above. And I can see that this has increased by 4 each time. So n squared plus 4 is my answer. And again, 3, 5, 7. This is going to have a gap of 2. So my rule will start n squared. Put my square number, let's compare my square numbers. I have them at the top here. So that is plus 9. Yep, plus 9, plus 9. So n squared plus 9. And the next one, we've got 3, 5, 7. So the difference goes up in 2s again. Let's compare with my square numbers at the top. Minus 1, minus 1, minus 1. So n squared minus 1. And then again, let's have a look. Yep, 3, 5, 7. My differences are 2. So again, my rule will start with n squared. Let's compare. Take away 8, take away 8, take away 8. So n squared, take away 8. Hopefully you've got them all correct. Let's look at something different now. So, the gap. Plus 6. Plus 10. Plus 14. Plus 18. Second difference. Plus 4. Plus 4. Plus 4. The second difference is the same. So this tells me it is a quadratic sequence. Now that this number at the bottom will be different each time we're going to do this. Remember, to get the number in front of the n squared, we divide it by 2. So this rule will start 2n squared. So just to summarise there, the second difference is 2. We start with n squared because we take that difference and divide it by 2. If the second difference is 4, if we divide that by 2, we get 2n squared. And if the second difference is 6, we divide it by 2 and get 3n squared. So we always halve the second difference to find the number of n squared that we have. So when things get slightly more difficult, we're now going to follow the rest of the steps on here. So the second difference was the same. Half the second difference and put that number in front of the n squared to give us, in this case, 2n squared plus bn plus c. The b and c are numbers we need to find out. These are 2 important numbers that we will need to find out. And the way we're going to do this, we're going to use the first 2 terms to help us. So I'm going to start with this term. In that term, I know that n was the number 1 because it's the first term. So I'm going to put that into my sequence. 1 squared is 1 times 2 is 2. N is 1, and there's no n there, so it's just the n's that are becoming 1s. And I know the first term of my sequence is a 7. So what I'm just going to do here is take that 2 to the other side, like that. So this here is to do with the first term. I am now going to do the same, but with the second term. n is 2. So 2 squared is 4 times 2 is 8 plus b times 2, which is 2n, plus c equals this term, which is 13. So I've put everywhere there's an n, I've put the number 2, and I've made it equal to the second term. And just like last time, sorry, that we're an n there, that should have been a b. I just take the 8 off both sides. This has come from the second term. We now have two simultaneous equations that I can solve. So this one looks, I've got a big amount of b, so I'm just going to write that on top. 2b plus c is 5. b plus c also equals 5. Notice that the c's are the same already. That's what's going to be great about this. With these simultaneous equations, the c's will always be the same. So every time I do this, I will always be subtracting. So 2b, take away a b, leaves us with b. C take away c is 0, equals 5 take away 5 is 0. So in this case, this b is actually a 0. But this says b plus c equals 5. So if b is 0, c has to be the number 5. So that means our nth term rule is 2n squared plus b, which is 0. So I'm going to miss that term out, plus 5. Oops, got carried away there. Equals 0 at the end. So all those quadratic equations I solved, that does not need to be there. And there's our nth term rule, 2n squared plus 5. I do have a feeling that you would like to go through another one. So let's have a look at this sequence, and we're going to follow the same idea, the same route, starting with first difference, second difference, third difference, fourth difference. I now take this number, divide it by 2, and that goes in front of the n squared. I will now take the first term and use that to let n equal 1. So that means 2 times 1 squared is 2, plus b plus c equals 11. Now, let n equal the number 2. So, 2 squared is 4, times 2 is 8, plus 2b plus c is 17. What I did forget to do up here, I'm going to take this number across, so b plus c is 9. And in this case, 2b plus c is also 9. Let's solve the simultaneous equation. So b is 0, c is 9, so we have 2n squared plus 9 is our nth term rule. Now, key steps. First, you must look at the second difference. You will actually get a first mark in an exam is actually taking the second difference, dividing it by 2 and putting it in front of the n squared. We then let n equal 1 and put your equation equal to your first term. We look at n equal 2, put your equation equal to the second term. We solve the simultaneous equation and we write out the rule. Here are 4 for you to have a go at. So pause the video here and please answer these 4. Let's go through the answers. First one, 7, 16, 31, 52, 79. This one goes up by 9. This one goes up by 15. And you don't have to do these in your head. You can use a calculator if you choose. At the moment, we're just mainly learning the method. And there we go. That is what the gaps are. Let's have a look at the second difference. Here we got 6. So divide that by 2. My rule starts with 3n squared plus bn plus c. When n equals 1, 3 times 1 squared is 3, plus b plus c equals the first term, which is 7. So b plus c equals 4. Now I'm going to let n equal 2. 2 squared is 4 times 3 is 12, plus 2b plus c equals 16. I'm just taking the 12 across to the other side. So my two equations are 2b plus c equals 4, and b plus c also equals 4. So I get the answer that b equals 0, therefore c is 4. So my nth term is 3n squared plus 4. Let's have a look at the next one. 7, 22, 47, 82, 127. So our first gap is 15. Our second gap is 25. Our third gap is 35. So our last gap is 45. This is going up by 10 each time. That means I divide that by 2. So my nth term is 5n squared plus bn plus c. First term, let n equal 1. So I get 5 times 1 squared, which is 5, plus b plus c equals 7. So b plus c equals 2. Let n equal 2. 2 squared is 4 times 5 is 20, plus 2b plus c equals 22. So 2b plus c equals 20. I will now solve my simultaneous equation. Oops, I wrote an extra 0 there. 22 take away 20 is 2. B equals 0. Now, for all these, you should end up with B equals 0, but they won't be on my next set of examples. So C is 2. So the nth term is 5n squared plus 2. The third one, minus 3, 3, 13, 27, 45. This one goes up by 6, and then by 10, 14, and 18. We look at the second difference. This gets divided by 2. So when n is 1, we get 1 squared is 1 times 2 is 2, plus b plus c is minus 3. When n is the number 2, 2 squared is 4 times 2 is 8, plus 2b plus c is 3. So b plus c, taking away 2 from both sides, gives me minus 5. And 2b plus c is also minus 5. 2b plus c, I'm just writing my two equations out. Let's solve the simultaneous by subtracting. So again, b is 0, so c has to be minus 5. The nth term is 2n squared minus 5. And the last one. 1, 16, 41, 76, 121. This goes up by 15. Then we go up by 25, 35, and then 45. So these are going up by 10 each time. Divide that by 2. 5n squared plus bn plus c. This is our nth term. Let n equal 1. So 5 times 1 squared is 5, plus b plus c equals 1. Let's let n equal 2. 2 squared is 4 times 5 is 20, plus 2b plus c equals 16. Taking the 5 off both sides up here gives me a minus 4, and taking the 20 off both sides here also gives me minus 4. So 2p plus c equals minus 4, b plus c also equals minus 4. We subtract the equations, so b is 0 and c is minus 4. The nth term is 5n squared minus 4. Okay, so in all these examples, b was 0. But it's not always 0. So this is more like an exam question now. We follow the same rules. First difference is plus 5. Plus 7, plus 9, plus 11. Take the number, divide it by 2. So we have 1n squared plus bn plus c. So let n equal 1. 1 squared is 1, plus b plus c is 6. b plus c equals 5. Let n equal 2. So we get 4 plus 2b plus c equals 11. So 2b plus c will equal 7. Notice now they don't match. So 2b plus c equals 7. b plus c equals 5. Subtract. In this case, b is 2. We can then look at this. If b is 2, c has to be 3. So our nth term rule is n squared plus bn, which is 2, plus c, which is 3. So the rule followed exactly the same. It's now b and c can be any number we think of. Have a go at this one yourself. Pause this video and have a go. Now let's see if your answer is correct. Let's have a look at the differences. 10, 16, 22, 28. Then we have, so I put plus 6 there, got distracted by the noise. So each of these is plus 6. This gets divided by 2. So at the moment, our nth term is 3n squared plus bn plus c. First term, n is 1. 1 squared is 1 times 3 is 3 plus b plus c equals 4. b plus c equals 1. Let's let n equal 2. 2 squared is 4 times 3 is 12. And the second term is 14. So we get 2b plus c equals 2. Let's solve the simultaneous equation. In this case, b is 1. Now, if b is 1, look at the bottom line, c has to be 0. So our nth term is 3n squared plus n. So I hope you found this video useful. This method works for all quadratic sequences. All you need to do now is a little bit more practice. Thank you very much.